Hey everyone, welcome back. Today we are going to solve problem number 1463, cherry pickup 2. First we will see the explanation of the problem statement, then the logic on the code. Now let's dive into the solution. So in this problem we are given a grid and two bots, right? And the bot 1 will be at the top left corner and bot 2 will be in the top right corner in the grid. So each cell has the number of cherries and the values in each cell represents the number of cherries. So there are certain conditions. So what we have to do here is that we need to use these two bots to pick the maximum number of cherries in the grid, right? To pick these cherries, there are certain conditions. So the bots can move in a way where the first bot can move to the right and second bot can move to the left simultaneously, right? Another condition is that the bot 1 can move to the right and where we can keep the bot 2 constant without moving, right? Next, we can move both the bots on the right direction. So whenever we move these bots, we can pick the cherries, and if the bots are in the same cell, only one bot can pick that particular cell's cherries, right? So whenever the bots pick the cherries from the cell, that particular cell becomes empty, right? So we just need to sum all the picked cherries and we need to find the maximum number of cherries collected by two bots. So now we will see how we are going to do this. So to solve this problem, we are going to use DFS approach, right? So here we have calculated the rows and columns of the grid. So here we have 2 rows and 3 columns. So initially we are going to pass RC1. So here RC1 represents the column of the robot 1, right? Then RC2 represents the column of the robot 2. So initially here the robot 1 will be at the 0th index, 0th column. So we are going to pass 0 here, and for the RC2, the robot 2 column will be the last column, right? So here we have 2, right? So we are going to pass 2 here, which is nothing but column minus 1 is going to be 2. So we are going to pass this one for the RC2, right? And this particular row will be helpful to keep track whether both the bots reach the bottom row or not, right? When we reach the bottom row, we have to return back. So initially this also will be 0. So now we need to calculate the cherries that both the bots can collect, right, at the starting stage. So first we need to check whether both the bots are on the same cell. If this particular condition is true, we just have to add the cell's value only once, right? We are just keeping that as my current cherry value, right? Else, if both the bots are in different cell, we just have to add both the cells value and that will be the current cherries collected, right? So as of right now, both the bots are in different cell, so cherries will be 5 here. So we can keep cherries as 5. So the 5 comes from the bot 1 is on the top left. So 3 plus the bot 2 is on the top right corner, which has 2. So it is becoming 5 here, right? So here we are going to have 2 loops. The first loop is for the first bot and second loop is for the second bot, right? So the 2 loops are going to range from RC1 -1 to RC1 plus 2. So here RC1 is 0 and -1 will be -1 and RC1 plus 2, right? So here we are going to have 2 here. Then we are going to have RC2 -1. So RC2 is 2. So -1 will be 1 and RC2 plus 2 will be 4. So what these ranges are? So by doing this, we are considering the cells for each bot, current position cell, left cell and right cell, right? So here if it is -1, we are going to come out of the loop, right? So this is not going to work. -1 is out of bound, right? So then it will be 0. So it will start from 0. then it will be 1. So by this we are also avoiding the last cell, since the last cell will be already calculated using the bot 2. Similarly, you can consider it for the second loop. So then if we are not out of bound of the grid, we will take maximum between the maxi. So here maxi will be our final output, where we are going to keep track of the maximum cherries collected. So we will take maximum between maxi and we will apply DFS. So we are going DFS, right? We have to reach the bottom row, then we have to come back and calculate, right? So then we are moving to the next row. So here NC1 and NC2 represents the column values that we are going to get from the loops, right? So when we reach the end, we will be adding the maximum and the current cherry value, and we will return, right? So we have to do this for all these stages. That's how the logic is. Now we will see the code. So before we code, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos and keep supporting, guys. So initially we are calculating the rows and columns from the grid, right? So here we have the DFS function where we are going to pass the row RC1 and RC2. So within that we have the if condition. So if we reach the bottom row, we have to return 0, right? Then we are going to calculate the cherries that are collected. So if both the bots are in the same cell, we will be just adding the current cell value, else we will be adding the cell values of both where the bots are located, right? Then we are initializing maxi as 0. Then we are writing the 2 loops where we are going to iterate for both the bots, right? So then we have the if condition to check whether the bots are going out of range. Then we are going to take the maximum between the maxi and the DFS function's return value, right? Then finally we need to add the maxi and the cherries, and we have to return that. So that particular value will come to this DFS function, which is within the maximum function, right? Then finally we need to return the answer. That's all the code is. Now we will run the code. As you guys see, it's pretty much efficient. Thank you guys for watching this video. Please like, share and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos. Keep supporting. Happy learning. Cheers, guys.